And now the final chapter, we are going to talk about factorial designs. Celebrate. Once you have mastered this concept, you have mastered the class. Are you excited? I'm excited. You're excited. But it's sometimes a little tough. So this might be one of the ones where you have to watch it a few times and go over some of these examples. I'm going to talk about basically 5 concepts, and I'm going to show it to you a bunch of times so that you can really understand what's going on with factorial designs. So a factorial design is used when you have multiple independent variables, and those independent variables are all nominal. So I want you to get familiar with this notation: A by B by C by D. Each of these letters represents an independent variable, okay? And then we'll replace these independent variables or those letters with numbers. So an A by B by C by D has 4 independent variables. And all of these are looking at multiple independent variables on one dependent variable. So no matter how many letters or numbers you see, you're always going to have one dependent variable, okay? So right here, we have 3 independent variables: 1, 2, and 3. Right here, we have 2 independent variables, right? The reason why we know that is because we are just counting the number of numbers, right? This is a 2 by 2 by 2, and this is a 3 by 2 design. So just take a moment. I'm going to ask you to pause the video in just a second, but I want you to tell me how many independent variables are in each of these studies. And this would be a great place to pause. Yep. Are you back? I can't really actually tell if you paused or not. So I hope you're back. Um, well, for this first one, we have 2. For the second one, we have 1, 2, 3. For this one, we have 2 independent variables. And for this one, we have 4 independent variables: 2, 3, 2, and 4. You might have noticed that all of the numbers, so we've just been counting them, right? But why are there different numbers? Well, the actual numbers that you see don't just represent the fact that there's another independent variable. The number in the place represents the levels of that independent variable. So if you have a 2 by 2 design, you have 2 independent variables, and each independent variable has 2 levels. If you have a 3 by 4 design, you still have 2 independent variables, right? But the first independent variable, variable A, has 3 levels, and the second independent variable, variable B, has 4 levels. If you don't remember what levels of the independent variable are, remember when you ask a nominal question, you give a specific number of choices. The number of choices that are available represent the levels. So if I ask you, what color is your hair, dark or light, then that would be 2 levels. If I say brunette, blonde, red-haired, other, then that would be 4 levels. It's the same variable, but the number of choices that are provided are going to tell us how many levels we have. So here are some examples. If I'm looking to see if the type of pet you have, cat or dog, and your gender, male or female, affect your level of anxiety, that would be a 2 by 2 design. I have 2 independent variables, type of pet and gender, and each has 2 levels. Then I could change it up, right? If it's type of pet, cat, dog, or lizard, that's 3 levels. male, female, non-binary, that's also 3 levels. That is a 3 by 3 design. Or if I add another independent variable and add a level to one of the independent variables, so what type of pet do you have? Cat, dog, bird, or lizard? That would be 4. Male, female, non-binary, 3. What social media platform do you prefer? 2, right? A 4 by 3 by 2 design. So if you're struggling with that part, rewatch this up to this point, right? And really make sure you understand that if I'm talking about a 2 by 2 design, I have 2 independent variables, A and B. I'm looking at how they affect one dependent variable, and the 2's represent the number of levels. So when we're doing a factorial design, there are 3 questions that you're going to ask. Is there a main effect of A? Is there a main effect of B? And is there an interaction? So let's say I wanted to look at how alcohol affects your level of intoxication. So that would be my variable A. How weed affects your level of intoxication, that would be variable B. And I want to see if weed and alcohol interact with one another, right? So if my first question is, does alcohol have an effect on how intoxicated you are? Is there a main effect of the variable A? Yes. Then my second question is there a main effect of B? Does weed have an effect on how intoxicated you are? Yes, right? Then my second question is, do weed and alcohol interact, and does a combination of the 2 of them affect how intoxicated you are? And hopefully you know the answer to this. It is yes. Both of them together are more powerful than one of them by itself. So I'm going to show you charts and graphs that allow us to see whether or not there is a main effect of A, a main effect of B, and an interaction, okay? We're going to do a bunch of examples so that you can see what it looks like in any combination. So in order to find the main effect of A, what we're basically doing is we're pretending like B isn't there. So we're going to average all the we're going to average out B so that we can only focus on A, right? If we want to find the main effect of B, we average out A so we can only see B. I'll show you what that looks like in a second, but think about that, right? Usually, we only look at one independent variable and how it affects a dependent variable. If we're also measuring another independent variable, but we only want to focus on one of those 2 independent variables, then we want to make it easier for ourselves, so we just pretend like one of those isn't there. So if I want to find the main effect of A, I'm going to ignore B. If I want to find the main effect of B, I ignore A. And then if I want to see if there's an interaction, all I need to do is see if the slopes of the 2 lines that we'll see are different. If the 2 lines are intersecting, or if they will intersect, that means that there is an interaction, okay? So let me just show you how these are made. You have 2 lines. You have line B1 and line B2, right? B1 is right here, B2 is right here. B1 goes from A1 to A2. That's our x-axis. So if I'm drawing line B1 and it goes from 5 to 5, it's right there. B2 also goes from 5 to 5. It's right there. These 2 lines are right on top of one another, right? Now, now that I have it drawn, I want you to see how we would compare the two. So if I want to see if there's a main effect of A, I want to see if there's a difference between these two levels. So maybe A is I take a drug, or A1 is I take a drug, A2 I don't take a drug, right? So I'm just going to pretend like B1 and B2 aren't there. The easiest way to do is just add all my A1s, 10, and compare them to my A2s, 10. There's no difference between them, right? If there's no difference between having the drug and not having the drug, then the drug doesn't have an effect on the dependent variable. Same thing with B1 and B2, right? 10 and 10. There's no main effect of B. No main effect of A, no main effect of B. Now look at the chart, right? They're not intersecting. Even though they're touching, they're not crossing, right? If you see anything like that, that would be an interaction. Since they are parallel, then there's no interaction. You can also tell whether or not there's a main effect of A or a main effect of B by looking at the graph. So what you do is, if I want to figure out if there's a main effect of A, I have to get rid of B. So I average B1 and B2. So I find the average of these two lines at A1, I find the average of these two lines at A2, and I find the line that connects the two of them. There's no difference between A1 and A2. A1 is 5, A2 is 5, right? So there's no main effect. I can also see if there's a main effect of B, right? So I average out A1 and A2. If you have 2 points and you find the average is going to be right in the middle, right? So this is the midpoint. And I just look. At this point, is there a difference between B1 and B2? There is not, right? So there's no visible difference between the two of them because they're both at 5. So if that's the case, then there's no main effect of B. Let's do another one, but we'll start with the graph, right? So I want to find if there's a main effect of A. So I find the average of lines B1 and B2, right? If you want to find the main effect of one thing, you average out the other thing. So to find the main effect of A, I average out B. So at A1, the average between these two lines is right here. And at A2, the average of these two lines is right here. Then I look to see if there's a slope in this line, right? A1 and A2 are different. A2 has a higher score than A1. So there is a main effect of A, right? Now I want to see if there's a main effect of B. I find the midpoint and I look to see between A1 and A2. So I average out those. Is there a difference between B1 and B2? There is not a difference. This is right here at 5, right, for B1 and B2. There's no main effect of B. Is there an interaction? These lines are parallel, so there's no interaction. So we have, if I want to double check my work, I can just look at the graph, right? 1 plus 1 is 2, 9 plus 9 is 18. That means A1 and A2 are different. There's a main effect of A. 10 and 10, there's no difference between B1 and B2. There's no main effect of B. And now we're going to do another one. Are you excited? Okay, so let's see if there's a main effect of A. So we compare A1 and A2. 9 plus 1 is 10. 9 plus 1 is 10. There's no main effect of A. 9 plus 9 is 18. 1 plus 1 is 2. There is a main effect of B because B1 is different from B2. That means that that independent variable has an effect on the dependent variable. So all of these scores in the boxes are scores on the dependent variable. right? So if I, back to like weed and alcohol, if I, maybe this is yes weed and maybe this is yes alcohol. This is no weed, but yes alcohol. This is yes weed, no alcohol, and this is no weed, no alcohol. And each of these represents your level of intoxication. So the reason why we split everything up is because we're looking to see at every combination of every level of the independent variables, right? So yes, 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 no, no, yes, and no, no, right? So when we look at the main effect, what we're saying is, okay, well, we have everything split up by all of the levels of the independent variable, but what we want to do is see, is there a main effect of just one variable? So the main effect is, in order to find the main effect of one variable, you have to pretend like one isn't there. And you could just compare A1 and A2. Okay, let's do it graphically. Main effect of A, main effect of A, we find the average of B, right? So at A1, B's average is right here, between here and here. At A2, B's average is right here. The line that connects these two is right here, but this line is flat. So there's no main effect of A. If it looked like this, with a slope, there would be a main effect. Now, let's see if there's a main effect of B. We find the average, and we look to see if B1 is different from B2. It is, right? So that means that there is a main effect of B, right? Because B has an effect on the dependent variable, which is on this axis. Is there an interaction? No, because these lines are parallel. And now we're going to do another one. Are you excited? Okay, so let's see if there's a main effect of A. So we compare A1 and A2. 9 plus 1 is 10. 9 plus 1 is 10. There's no main effect of A. 9 plus 9 is 18. 1 plus 1 is 2. There is a main effect of B because B1 is different from B2. That means that that independent variable has an effect on the dependent variable. So all of these scores in the boxes are scores on the dependent variable, right? So if I, back to like weed and alcohol, if I, maybe this is yes weed and maybe this is yes alcohol. This is no weed, but yes alcohol. This is yes weed, no alcohol, and this is no weed, no alcohol. And each of these represents your level of intoxication. So the reason why we split everything up is because we're looking to see at every combination of every level of the independent variables, right? So yes, 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 no, no, yes, and no, no, right? So when we look at the main effect, what we're saying is, okay, well, we have everything split up by all of the levels of the independent variable, but what we want to do is see, is there a main effect of just one variable? So the main effect is, in order to find the main effect of one variable, you have to pretend like one isn't there. And you could just compare A1 and A2. Okay, let's do it graphically. Main effect of A, main effect of A, we find the average of B, right? So at A1, B's average is right here, between here and here. At A2, B's average is right here. The line that connects these two is right here, but this line is flat. So there's no main effect of A. If it looked like this, with a slope, there would be a main effect. Now, let's see if there's a main effect of B. We find the average, and we look to see if B1 is different from B2. It is, right? So that means that there is a main effect of B, right? Because B has an effect on the dependent variable, which is on this axis. Is there an interaction? No, because these lines are parallel. Let's do another example, okay? So the average of these two lines, if I average out B, I get a line that looks like this. I average out B to find the main effect of A. There is a main effect because this line is sloped. I want to find the main effect of B, so I average out A. I just find that midpoint of A, and I look up, and then wow, B1 and B2 are different, right? So because there's a difference between B1 and B2 at this point, that means that there is a main effect of B and a main effect of A. Do these lines cross? Let's see. Nope, no matter how far they go out, they will never cross. So there's no interaction. Let's look at the chart. A1 and A2, 6 and 14. Yes, main effect. 14 and 6. Yes, there's a main effect. Now let's look at some where there is an interaction, right? We see that there's an interaction because these two cross right here, right in front of your face. Now, is there a main effect of A? Is there a main effect of B? Don't look up here. No spoilers. So let's look at the chart, right? Or the graph, the data, whatever. So 1 plus 9 is 10. 9 plus 1, also 10. 1 plus 9 is 10. 9 plus 1, weirdly enough, also 10. A1 and A2 are not different. B1 and B2 are not different. There is no main effect of A, no main effect of B. Let's look over here. So I want to average out A1 and A2 to see if there's a main effect of B. Well, right here, these scores are exactly the same. So there's no difference between B1 and B2 at that point. There's no main effect of B. I average out A1. I average out A2. And I find the midpoint of these B lines, right? So at this point, this is the midpoint. Between these two, this is the midpoint. I draw that line. That line is flat. There's no difference between them. That means that there is no main effect of A. How about this one? There is an interaction, right? Look at that. They cross right there. Is there a main effect of A? Is there a main effect of B? Let's look at the chart. So we have A and A. We find that midpoint, which is right here, and then we draw the line and see if B1 and B2 are different right here. Since they're crossing right at that midpoint, that means that there's no difference between B1 and B2. If there's no difference between B1 and B2, having the drug, not having the drug, having a cat, having a dog, right? That means that there's no main effect of B. Let's see if there's a main effect of A. So we find the averages of B1 and B2 right there, of B1 and B2 right there, and there is a slope to that line. That means that there's a difference between A1 and A2. Let's double check. 6, 14. There is a main effect of A. 10 and 10. There is no main effect of B. Okay, don't look up here. Is there an interaction? Well, just because they're not currently crossing, because they have intersected, right, and if they continued on, they will, that means that there is an interaction. So there is an interaction, yes. Now the question is there a main effect of A or B? So let's look at B. We look at that midpoint. Is there a difference between B2 and B1? Yes, there's a difference between B2 and B1, so there is a main effect of B. How about A? Well, we have the midpoint here, B1 and B2. We have the midpoint here, B1 and B2. but that is a flat line, so no main effect of A. Let's check our math. 10, 10, yep, no main effect of A, but 14 and 6, there is a main effect of B. One more. Oh, you love these. You love these so much. You're so excited. You cannot get enough of them. So these are crossing. So there's an interaction. Let's look at the graph and see what we can see. Between A1 and A2, we have 2 and 10, main effect of A. We have 10 and 2, main effect of B. Okay, let's check the graph. Midpoint, midpoint, find the slope of the line. There is a slope. That means that between A1 and A2, we have a main effect, right? We average A1 and A2 out. We look at the midpoint. We compare B2 and B1, and there is a difference. That means that there is a main effect of B. So we're saying A, whatever variable A is, has an effect on your intoxication. We're saying whatever variable B is has an effect on your intoxication, whatever, right? And then A and B together combine and have an amazing effect on your level of intoxication. Okay, we've done 8 examples where you've had the answers right in front of you. Now just take a break and see if you can figure this out by yourself. So is there a main effect of A? Is there a main effect of B? And is there an interaction? And feel free to pause and, I'll be here. Yeah, no, my students are paused right now, so they can't hear this. This is happening while, yeah, no, I'm doing a lecture. No, they'll unpause it eventually, and they'll have to go back. So, yeah, no. Oh, oh, they're back. Hey, so what did you decide? Let's see. If you looked at it graphically first, you might go A1 and A2, average out B1 and B2, B1 and B2. There's a slope of this line, so there's a main effect of A. We find the midpoint of these two lines, and we see that there's a main effect of B, and these lines cross, so there's an interaction. Let's double check. 13 and 5, main effect of A. 7 and 11, main effect of B. If you got yes for main effect of A, yes for main effect of B, and yes for interaction, you are correct. Here's another one. When you are ready, pause, and I will be here when you return. I'm assuming that you have paused. Now, pause the video. Is it paused? I don't know how to do this. It's very hard to be interactive. I'm just going to assume that you paused, you did it, and we're back, right? So let's check the graph first. We want to see if there's a main effect of A. So we want to ignore B1 and B2, right? So we're comparing only A1 to A2, 17 to 5. There is a main effect of A. Now we want to do the opposite. We want to see if there's a main effect of B, right? So we ignore A1, ignore A2, 12 and 10. There is a main effect of B because B1 and B2 are different. They cross right here. There's an interaction. We look to see if there's a difference between A1 and A2 at these midpoints. So we're finding the average of the B1 and B2 lines. There's a slope, which means that there is a main effect of A. We can also look to see if there's a main effect of B by finding this midpoint and seeing if B2 and B1 are different right here. And they are. So there is a main effect of A, there's a main effect of B, and there is an interaction. Okay, you know the drill now. Pause, I'm right here. Great, you're back. Hopefully, right? Or not. Just pause right now before it's too late. Or don't. I don't know. Who cares? Free country. So let's look. B1 and B2, 19 and 9. There is a main effect of A. We have A1 and A2. We have 15 and 13. There is a main effect of, did I say A before? Main effect of B, right? 19 and 9. Main effect of A, 15 and 13. Let's double check it, right? Midpoint here, midpoint here. Very slight, but it's there, right? And then midpoint here, and there is a difference between B1 and B2, so there is a main effect of B. And if these lines were to continue on, eventually they would cross, and that does mean that there is an interaction. We did it. That's everything. We're done. We did the class. This is all the material. So make sure you are familiar with this for the purpose of the upcoming test so that you kick butt, so many butts. I want all the butts to be kicked by you. Review this as many times as you want, and then we'll also go over it in class or something, office hours. I don't know. What is the world? So take care, be well, wash your hands, and we'll definitely talk soon. Oh boy, totally forgot that I gave another sample problem. Why would I do 4 sample problems? We'll do it. Pause whenever you're ready. Welcome back. Okay, midpoint, midpoint, right? So we're averaging out this line and this line. And the average of those two lines looks like this. And that line has a slope. So that means that there is a main effect of A. We average out A1 and A2. This is where the average is. We look to see are B1 and B2 different at this point. They are. There's a main effect of B. They cross. There is an interaction. 9, 14, 9, 14. Main effect of A, main effect of B, interaction. This might be a thing that you need to review a couple times. It does feel like just a new way of understanding the world. So definitely give yourself some time. Watch it, really try to digest it, sleep on it, come back to it, give it time to sink in, and then it will start to make sense. But just remember, we're just looking to see if 2 independent variables, all the ones that we've been doing are 2 by 2. We're not going to make it any harder than that. We're just doing 2 by 2 designs, right? So we're trying to see if these 2 independent variables affect a dependent variable. So the way we do that is we look at each variable by itself. We start off having all the data together, so we just focus on it one at a time, right? We look at B1 compared to B2. Does B have an effect on the dependent variable? Yes or no? We look at A1 and A2, and we average them out, right? Is there a difference between A1 and A2? Does A have an effect on the dependent variable? And then do all of these combine and interact with each other in some way? That's all we're asking. It feels complex when you first start with it, but once you realize that it's the same thing that we've been doing, we're just adding another couple steps, it's a lot easier. So thank you for sticking with it the entire semester. This is kind of a heady thing, but once you've mastered this, there's not much else in this class that can take you down. So let's get ready for that final. You have a few more assignments to do, but we got this. Take care, talk soon, wash your hands, and I really hope I didn't have a sample problem 5.